Okay, good evening students. Today we will discuss about the new topic, that is dipole moment. Now what does this dipole moment means? What is the definition of dipole moment? First we'll go to the definition, then we'll come proceed about the examples. So the definition of dipole moment will be the product of magnitude of charge that is denoted by q, and the distance between the separation of positive and negative charge. So what does this positive and negative charge means? So let us take an example of HF. This is hydrogen fluoride, and since we know fluoride is more electronegative than hydrogen, so that is why the more electronegative atom will attract toward itself. So since they are attracting electrons towards itself, so they will acquire delta negative, and since they have already transferred the electrons towards itself, that is why they will acquire delta positive, and this arrow mark is known as the dipole moment. So and the mathematically it can be expressed as mu is the dipole moment, is the sign of dipole moment. Mu equal to q dot r. Q means charge, r means distance of separation between positive and negative charge, and the unit is dBi. So also we know that dipole moment is also related to polar and non-polar molecule. Now what does this polar and non-polar molecule means? Polar molecule means the polar molecule contains the polar bonds where the sum of the dipole moment is not zero. That is, since fluoride is more electronegative than hydrogen, then they will acquire some charge, and that is why here the dipole moment mu is not equal to 0. We will give better example, then it will be more clear to you. Now let's come to the non-polar molecule. Non-polar molecule are those molecules where the sum of the dipole moment is 0. Okay, let's come to the example which will be more clear to you. Now all of you know the rubber band. Okay, since let us take a rubber band. Okay, we have taken the rubber band, and we have done, we have taken the rubber band and we have compressed from the both side. When we have compressed the rubber band from the both side, then the resultant force will be like this. Okay, rubber band is compressed from both sides. When the rubber band is compressed from both sides, from both ends, then the resultant force will be like this. That means, will the rubber band will be stressed? Will the rubber band will be torn? No, the rubber band will not be torn. That means the dipole moment mu is not equal to 0, where that is water molecule. I have given one example. Now let us take an example of carbon dioxide. Now again let us take the rubber band, and we have done, we have stressed from the both ends, from the opposite ends. Okay, if you stress the rubber band from the opposite end, then the middle portion will be torn. That means, since the rubber band has been torn, that is why mu is equal to 0. That is why when, and we have told that when the sum of dipole moment is 0, then it is known as non-polar molecule. So it will be what? Non-polar molecule. See, here I have written, when mu equal to 0, that is, in terms of carbon dioxide, mu equal to 0, that is non-polar molecule. Where in case of water, here see, since there are the resultant dipole moment will be on the upward direction, that is why mu is, there will be the value of mu, that is dipole moment. That is why it is a polar molecule. Since O is more electronegative atom than hydrogen, that is why oxygen is attracting electrons towards itself, while in case of here oxygen is more electronegative than carbon, that is why they are attracting towards electron towards itself. So here the mu equal to 0, here mu equal to not equal to 0. Okay, this is all about the dipole moment related to polar and non-polar molecule. Hope all of you have understand.